Here's another presentation I put together named Hexadecimal Made Simple for Computing. I'm not getting into all the super duper math and all that stuff. This is just hexadecimal made simple for computing purposes. So binary and hexadecimal and decimal explained. So binary comes from the term bi, which means two. Oh, excuse me, I'm yawning. So in binary, there are only two numbers. They are 0 and 1. 0 being off and 1 being on. This is also known as machine language, as it is the only language that computers can understand. Decimals, or decimal, comes from the term deci, meaning 1/10 or 1 out of 10. Either way, it effectively means 10, no matter how you put it. So base 10 is how it's generally referred. And there are only 10 numbers, 0 through 9. Hexadecimal comes from the term hexa and deci, meaning 6 and 10 respectively. Commonly known as base 16, hexadecimal uses only 16 characters, and they are the same 0 through 9 that you find on decimal, but now you're adding the characters A, B, C, D, E, and F. So as you can see, that hex number A is equivalent to decimal number 10 on this top chart up there. And hex number B is equivalent to decimal number 11, all the way up to hex number F being the equivalent of decimal number 15. Just below that, the binary chart shows the base 2 numbers from the power of 0 to the power of 7. Keep this chart in mind, as it's the easiest way to learn binary. The zeros at the bottom are used to calculate the binary numbers when the bits are turned on, meaning set to 1 instead of set to 0. Again, base 2 uses a base of 2 with the superscript corresponding to 0 through 7. So this first example, you'll see a binary number which is equivalent to decimal number 1 and binary number 1. It's 2 to the power of 0. And below that, you see 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8, and so forth down the line till you get 2 to the power of 7th is 128, and that's what you saw on that previous slide. So base 16 uses a base of 16 that divides into any decimal number of choice and may leave a remainder. Example, the number 55 divided by 16 equals 3 with the remainder 7. In a base 16, there are only 2 characters in a number. Since the number will not go above 255, the maximum hex number can be FF and the lowest 00. Let's look at some number examples. So check out this conversion chart. First thing you want to do, the decimal number is 16 that we're going to convert to binary, and then we're going to convert it to hexadecimal. So if the decimal number is 16, to convert it to binary, the first thing you want to do is figure out which bits to turn on for the binary. So if you look at this example, you see the decimal is 16, so all you have to do is turn on, meaning convert from 0 to 1 under 2 to the 4th power, which is 16. And so that full binary number is 0. So 00010000. And how you essentially can read that is there are 0 bits turned on 128, 0 turned on 64, 0 32, 1 turned on for 16, 0 for 8, 0 for 4, 0 for 2, 0 for 1. So whatever numbers are turned on, that's what you add up. So in this case, only 16 is turned on, so that's all you add up. So 16. So 16 decimal, that's how you write it out in binary. And so for hex, since you only use 2 characters or 2 slots, the 16 slot and the 1 slot, or the ones place slot. So think of them as places. So you got the 16th place and the ones place. All right. So in this case, you take the number 16 from decimal and you say 16 divided by 16 is 1. And so you get 1 in the 16th place to make 16. And then in a ones place, there's nothing left. There's no remainder. So it's 16 divided by 16 gives you 1. And there's no remainder. So the next slot is 0. So the 16th place slot is 1. The ones place slot is 0. So the hexadecimal reads 1 0. Don't read it as 10. You confuse yourself. Read it as the 16th slot is 1. The 1 slot is 0. Next number, do the same thing. Okay. The decimal number is 48. So since this presentation is more focused on hex, I'll go over to the binary one more time. So since the decimal number is 48, the slot you want to get to 48, you want to add up the 30, you want to turn on the bit for the 32nd slot and the 16th slot. 32 plus 16 gives you 48. So you see the binary number is 00110000, because all those other slots are not necessary, because the easiest way to get to 48 is by turning on bit 32 and the 16th slot. So all of the rest of them are off. Now, when we start talking about hexadecimal, same thing in terms of what we spoke about on the previous chart. The number 48 in decimal divided by 16 gives you 3. Okay? 3 times in the 16th place. That gives you 48. 16 times 3 is 48. So there's nothing left. There's no remainder. So in the ones column, 0. So 3 16s in the 16th place, 0 in the ones place gives you 48. Next decimal number is 21. We'll do the same thing. We're going to turn on the 16 column, turn on the 4 column, and turn on the 1 column. That gives you 16 plus 4 plus 1. That gives you 21. All right. Binary is 000100101. Now, hexadecimal is very similar, but it's more mathematical in terms of using division. So you take 21 divided by 16 one time. 16 goes into 21 once with a remainder of 5. So you take that remainder and you put it in the ones place, right? So the hexadecimal nomenclature for decimal 21 is you have 1/16 and 5 ones, which gives you 21. So the answer is 1 5. Don't look at it as 15 again. 1 5. Next number, decimal 51. Follow along with me. It's the same. So if the decimal's 51, to get the binary, the simplest thing to do, turn on that bit in the 32nd place, turn on that bit in the 16th place. That gives you 48. And then From there, you only need 3. I'm sorry, I actually wrote this wrong. So that 4 column should be off. It should be a 0, but the 2 and the 1 should be on. So 32 and 16 is 48, plus 2 is 50, plus 1 is 51. And then the hexadecimal, you're going to say 51 divided by 16. 16 goes into 51 3 times for 48 with the remainder 3. So it leaves you with 3 ones. So the hexadecimal answer is 3 16s and 3 ones give you 51 decimal. It's written out nomenclature wise as 3 3. Again, don't look at it as 33, but look at it as 3 3. 3 16th place, 3 ones place. Here's another, number 82. So in this one, convert that decimal 82 to binary. You turn on the bit in the 64th place, turn plus the bit in the 16th place. That gives you 80, plus a bit in the 2's column to give you 82. So that reads as binary 01010010. Now let's convert that decimal 82 to hex. If you say, how many times does 16 go into 82? You say 5 times. That gives you 80, right? With the remainder 2. So if it goes into it 5 times with the remainder 2, that simply means your hexadecimal number is going to read 5 16th column, 2 in the ones column. So 5 16s and 2 ones give you 82. Next number, decimal 224. That's a pretty simple one. Convert it to binary. Turn on the bit in the 128th column, the bit in the 64 column, and the bit in the 32 column. Add those up. 128 plus 64 gives you 192, plus 32 gives you 224. So the binary reads 1 1 1 0 0 0 0 0. Hexadecimal, same principles. All right, as before. 224 divided by 16 is 14. How do you write 14 in hexadecimal? It's the number E. No remainder. So 16 times 14, or 224 divided by 16 is 14 with no remainder. So there's 0 ones. So the hexadecimal nomenclature is E0, meaning E 16th place, or E, aka the number 14 in hex, 0. So E 16th place, 0 in the ones, you get that number. All right. So remember, think of E as the number 14, because that's how, when you convert it to decimal, that's what that number is. So E is 14. Same, number 159. Convert it to binary, so you get 1, turn on the bit in the 128th place, the bit in the 16th place, the bit in the 8th place, the bit in the 4th place, and the 2 and the 1. That gives you 159, and it reads 1 0 0 1 1 1 1 1. Hexadecimal wise, 159 divided by 16 is 9, with a remainder of 15. And how do you write 15 in hex? It's F. So the hexadecimal nomenclature for decimal 159 is 9 16th place and F in the ones place, or 15 in the ones place. It just reads 9F. And we can continue this on. Next decimal number, 137. So you turn on 1 bit in the 128th place, 1 bit in the 8th place, that gives you 136, and 1 bit in the ones place, that gives you 137. Reads 1000101, and then you go down to hexadecimal, and how that reads is 137 divided by 16 gives you 8 with the remainder of 9. So that basically means 16 times 8 will be 128, and the remainder is 9, 1. So 8 16th place, 9 ones leaves you with, or 8 times 16 plus 9 times 1. However you want to look at it, the nomenclature is 8, 9. Not 89, but 8, 9. And here's a resource that you can look up to go over hexadecimal numbers.